Welcome back to the channel. Hope everybody's doing well. And in today's video we are taking a further look at our two little LCR meters that I looked at in the last video. Primary reason for this is looking at the 100 microhenry reading on the DMMCheck Plus that I have here, that I compared all the readings to on these, specifically these two, but I also brought in the LCR1020, which is the current instrument that I use. The problem with this was, if I plug on my LCR1000, this gives a reading very close to the reading on the certificate for the DMMCheck Plus, which is 107.2 microhenries. And we are on RS, so we don't want that. There's S. So we're currently 107.8 microhenries, 107.2. That's pretty much within spec. I've not got a problem with that. But if I plug on my Fnirsi here, we get 103.64. And if I move it over to my Zoyi unit there, we get 104.4951. So it seems to be quite a bit out, which is a bit confusing really, because all the other values are fairly reasonable. Now when I first set this up, you can see I now have it switched to slow. Somebody pointed out to me on the original video that I had this set to medium speed, which does make it more erratic. That's medium there. So you can see the reading's a lot more erratic. That was my bad. We go to fast, it gets even more erratic. Well, we go back to slow and you can see it steadies the reading down. So that solved one of the problems that I had specifically with the Fnirsi unit. Another one was the frequency that we are using. So I thought at the time, I seem to remember that the certificate for the DMMCheck Plus was 1 kHz. It wasn't. It's actually 10 kHz. I'm using 1 kHz because that's what I use for all the motors that I test. But we can change the frequency up. There's our 10 kHz reading there, which should match the certificate. And we are 103.7165. So not much of a difference really. And if you look at the specs for the Fnirsi instrument, there isn't much of a difference with the accuracy of the 1 kHz to the 10 kHz for the 100 microhenry that I'm reading. We can do the same. Let's go. So interestingly enough, our Zoyi does seem to respond a little bit, and we now go to 106.55, which is fairly close to our 107.2, but doesn't really explain why there should be such a reading between the two. Kilohertz, and we go to 100 hertz, 20 hertz. So there seems to be a jump. We're now 105 microhenries at 1 kilohertz. Now the other thing that was suggested was a calibration on these units. Generally speaking, I find that the calibration for inductance measurement doesn't make a vast amount of difference. There's a reason for that, because although they call it a calibration, it's a little bit cheeky. It's not a calibration. What you're doing is you are zeroing the leads for resistance measurement and taking out the capacitive reactance. So unless you have a particular inductor with a very low resistance, or you hit some strange resonance issue between the capacitance of the leads and the inductor that you're testing, it doesn't really affect an awful lot. Okay, so we can do a calibration on our Fnirsi. It takes about a minute-ish. We're asking for a short, so we apply short to there, which you will see there. And I'll probably cut out what it does, hit OK, and it should start. I'll probably cut this little bit out so that you're not waiting around. Okay, so we have finished our calibration for the short. What we now need to do is go over to the open, unplug the leads, so they just sit here now, all open, and then we can start that and it will do the same again. Okay, so we've come back with calibration for open is all finish. So now we long press, and long press again to get out of that, and we are now calibrated. Go on to our DMMCheck Plus again, and you see it's not really made an awful lot of difference to it. So we can do a calibration in a similar manner with the Zoyi unit. This is our short that we've set up here. It runs through it and it said it's okay. You can actually put in more values for this one. You can test the bridge to 10 milliohms, 100, 1 ohm, 10R, 100R, 1K, 10K, 100K, 1 mega ohm, 10 mega ohm, and then finally our open, which we can do again. Start that off so we can let that run through its calibration, and we'll see if that affects the reading on here. But at this moment in time we are all a little bit puzzled by it all. And we get our little beep and we are all okay. So that's done that. Go backwards again, and we can go on to our 100 microhenry. We're back at 1 kilohertz. 104 at 1 kilohertz, not made an awful lot of difference. We'll up the frequency. We do go up to 106. Same doesn't happen with our Fnirsi, unfortunately. So 1 kilohertz, so we're 103.81. Let's got to our 10 kilohertz. Doesn't make much difference. We'll take it up to our 100 kilohertz, actually, see if that does anything. That drops it lower, which is completely opposite response to our Zoyi. That's the curveball I wasn't expecting. There we go around to, yeah, we're 100 hertz then, aren't we? 105, 104. Yeah, don't know. I don't know fully how the calibration works on this, whether it does all frequencies when you set it up, or whether it just does it at the frequency that you had the instrument set to at that time. There's not much information on how these calibrations work really with these instruments. So the other instrument I do have for measuring inductance capacitance is this actual bench meter from Anbai, the AT2817A. It's quite an expensive instrument. Its tolerance is allegedly 0.05%. plus or minus 5 digits, which I suspect that it's not that. We will measure our 100 microhenries. No, we won't, because we'll select that first. Let's go LSRS. We'll put him on to our 100 microhenries. And on this one we get 109.15, which is pretty close to what it's always been with this instrument. I regularly measure the DMMCheck Plus with this instrument, and the values are consistent across the time span that I've measured it with this instrument. Although 109 is a little bit high, it's certainly not 0.05% within the 107.2. But this is allegedly more accurate than the BK981 that's used by DMMCheck Plus. So I don't really know which instruments are out. At this moment in time it would kind of point to the Fnirsi being the problematic unit, because we can get the Zoyi to match a little bit, and given the whole test setup and the errors that can creep in, probably say that the test certificate from DMMCheck Plus is the correct value. But there are other methods that you can use to try and measure inductance, so I'll perhaps give some of them a go and see how they turn out. But in the meantime I'll just put this table up. You can peruse, and these are the values that I've measured with all the different instruments. So you can measure all the Q and the resistance and so on and so forth. I've tabulated all them up, and there's no real major differences between the units other than the actual inductance value. So I could well regret doing this, but we're going to give it a go anyway, and we're going to try and calculate this 100 microhenry inductance using a signal generator and this millivolt meter here. Currently I'm just set up with a 20 kilohertz signal coming out. I'm not connected to anything. We've just got the millivolt meter reading the output from the DQ02. What I will need to do is when I connect this onto the 100 microhenry inductor, the voltage on this will drop. I will need to adjust the frequency so that I've got half of this voltage. So at 1.0695 we're currently looking for 535-ish millivolts. Let's see what frequency is there then, and I will plug onto our 100 microhenries. Plugged on there, and you can see we've dropped to 281 millivolts. So what I now need to do is adjust up our frequency. Just a little bit steady just to let it settle. There's 488, 487, so I probably need to go up in 1 kilohertz now. Okay, that's 45, and we have 531 millivolts there, which is pretty close. So I will need to take those figures. We're actually reading 44.997 there, correlates with the 45 kilohertz up there. So I'll need to take these figures and plug these into some maths, and we'll be able to calculate the value on this 100 microhenries inductor, which is going to be somewhere very close to 100. Doing that in my head. Yeah, I'll need to get the calculator out first. So putting this through our maths, our little formula, we end up with a inductance of 101 microhenries, which is closer to 304 readings of the Fnirsi and the Zoyi rather than my LCR300 and the test certificate, which is quite intriguing, isn't it? The actual halfway voltage should have been 534.75 and we're 532.65, so you could just take him up just a little bit more and see where we end up with. 4.3 is going to be too much, isn't it? Go across again. So yeah, we've got 45.23 kilohertz will be our final one, but that will just take it close to the 100 microhenries. Now, I will leave a link to the maths that tells you how to do this in the description box below, so you can go and check that out yourself should you want to, but it's a fairly well documented procedure to use this. How accurate it is going to be dependent upon how you're measuring it. Generally they would do it with an oscilloscope, but I've got this available to me and I kind of feel this will be more accurate than an oscilloscope. So I don't have much in the way of other inductors around really in the microhenries range. I do have this little SMD one here that I've soldered a couple of wires onto, and on our Fnirsi it's coming out as 94. Our Zoyi it's coming out as 94 as well, and to swap over connections. Our LCR300 it's coming out as 95. Going on 96 microhenries, so again 2 units seem to be reading a little bit lower. The only other thing I do have is this 120 microhenries, which if I look on my LCR300, that's this little fellow here, we're looking at 116. Go on to my Fnirsi, and we are 113 again. 13.8, 114, so again we're a couple of microhenries. Not quite as bad as the DMMCheck Plus. So whether there is something within the DMMCheck Plus that is being a little bit of an issue just to these two units. 113, a little bit lower on the Zoyi there. 114, that's what's 13.7. So a little bit lower on the Zoyi unit there. So I don't really know. A bit of a inconclusive outcome to this video really. I'm not really sure how well I could progress it. I could set up an oscilloscope and do the inductance measurement the more traditional way, using a scope instead of the SP millivolt meter I had. I guess I could try and find a local calibration shop that's got good instrumentation and send this out to them, even if they just measure the component values here and don't worry about the voltage and current output. I could give that a try, but how well I will get a response to that. Generally speaking, calibration houses aren't really interested in an oddball instrument like this unless you're using them a lot. They'll just laugh at me probably. So yeah, not a very good outcome to this one, but that's all we can appear to do at this moment in time. That'll be it for this video. Thanks very much for watching, and I'll see you again in the next one.